So we're gonna take kind of a fun break and talk about aldehydes and ketones that your book describes as interesting. Interesting aldehydes and ketones. And some of these are going to be molecules, chemicals that you interact with in your regular everyday life, and some of them won't be. One of the things that makes aldehydes and ketones interesting is that most of them, many of the aldehydes and ketones are fragrant. They have good smells, which is kind of nice because most of the chemicals that we deal with, they don't have good smells. So the aldehydes and ketones that have good smells are much appreciated when we're working in the lab. Here are a couple that you have almost certainly encountered. This is an aromatic ring that also has a carbon-carbon double bond, an alkene, and an aldehyde group attached. This molecule is called cinnamaldehyde. And I bet you can't guess what cinnamaldehyde is used for. Cinnamaldehyde is the cinnamon fragrance or flavoring. It's used in food products like gum, candy, cinnamon extract, things like that. And then it's also used for cinnamon scented candles or air fresheners or things like that. Cinnamaldehyde is a natural product, so we can extract it from a plant. It is also very easy to synthesize, so we can make it in the lab and produce it either way. Number 2 that I'm going to show you is also aromatic. It has an alcohol, OH, and it has this functional group that we don't spend a lot of time talking about, but that's the ether functional group. And then here is the aldehyde functional group. And this molecule's name is vanillin. And I bet you cannot guess what this is used for. Vanillin is our vanilla fragrance and also vanilla flavoring. So it's used in food products, it's used in vanilla extract that you would use for baking, it's used in vanilla scented candles or soaps. And like cinnamaldehyde, vanillin is a natural product, can be extracted from the vanilla bean. Very easy to do the extraction. In fact, you could do it at home. If you're bored and you don't have a lot of stuff going on, you can get vanilla beans. You can put them into vodka, which is the ideal solvent for this, and you just leave them in there for a while, and the vodka extracts the vanillin out of the vanilla bean, and it's your way of making homemade vanilla extract, which is wonderful. Vanillin is also very easily synthesized in the lab, which is how we get artificial vanilla extract in the baking aisle, which is significantly cheaper. And then last but not least, I've got one for you that's not aromatic. This one has a carbon-carbon double bond, and it has aldehyde group on the end there. And this molecule is called citronellal. And I'm guessing that you can probably figure out what this is used for. This is citronella, what we commonly call citronella. And I don't think, I've never heard of us eating citronella, so I don't think citronella is a flavoring. It might be. I'm just not familiar with that. But citronella fragrance is common. It's used as a way of hoping to deter insects. So you can buy citronella scented candles for your porch, or oils that you can burn in like a tiki torch, or citronella smelling wristbands and things like that that you can use to repel insects. So those are definitely fragrant aldehydes and ketones, and I don't really like the smell of citronella, but I definitely like the smell of cinnamaldehyde and vanillin. They smell very good. So here's a couple more aldehydes and ketones that are interesting, but not for their yummy smelliness. This little guy right here, so this is the tiniest of all of the aldehydes. It just has 2 hydrogens on it. This guy's name is methanol, but its common name is formaldehyde, which maybe sounds familiar to you. We did talk a little bit about formaldehyde when I was talking about the metabolism of ethanol, the alcohol ethanol, drinking it and what our body does with ethanol. Methanol is a molecule that is produced in our bodies when we metabolize not ethanol, regular alcohol, but when we metabolize methanol. So this is produced in our body during the metabolism of methanol. Methanol is never the alcohol that we are attempting to drink. Methanol is made as an unwanted byproduct during the synthesis of ethanol. Like if somebody is moonshining, making ethanol that way, or even if it's being made industrially on the up and up, methanol is a byproduct of that synthesis. Methanol is not something that anybody wants to put inside of their body, primarily because methanol turns into formaldehyde or methanol. And formaldehyde or methanol is extremely toxic. Formaldehyde is very toxic. So people who consume formaldehyde, if it's just a teeny tiny amount, it's probably not going to affect you. But consuming larger quantities of formaldehyde can cause blindness. They can cause you to go into a coma. They can cause you to die. Our body is just, there's a very small limit as to how much formaldehyde we're able to handle at any given time. Formaldehyde used to be used very commonly as a biological preservative. So it was, not that long ago, a preservative for biological specimens And I'm sure that in some places formaldehyde is still being used as a preservative because in its defense, it's a great preservative. So those cats that you've got to digest in your anatomy and physiology class, if you're digesting real cats, even 10 years ago, maybe even less than 10 years ago, those cats would have been preserved, soaked, and treated with formaldehyde to help slow down, significantly inhibit the decay process. But because formaldehyde is hazardous, even if we're not consuming it, just inhaling the formaldehyde fumes, we know that is hazardous for humans. And so we have moved towards other preservatives that are not as effective as formaldehyde, but they're also not as toxic as formaldehyde. So it's kind of a give and take. The last but not least that I want to show you this molecule, which is, it's got two CH3 groups on there. I'm going to go ahead and fill those in. This molecule is called 2-propanone, but commonly we call this molecule acetone. And many of you have probably interacted with acetone. First of all, this is a great nail polish remover. It's a good paint solvent in general. Nail polish remover, not removed. These days, when you go to the store and you buy nail polish, most of the time what you're buying is a chemical called ethyl acetate, which is also a good nail polish remover. But acetone is still out there on the market. You can still purchase acetone nail polish remover. If you're getting like gel nails done or some kind of thicker than normal nail polish put on you, you will almost certainly be needing to use acetone to remove that type of nail treatment, just because the paint is definitely more adhesive and harder to remove. Acetone is not hazardous for you. It's not great to breathe a lot of acetone, so people who are working in nail salons should definitely be working in a ventilated environment. But for the everyday person, removing your nail polish with acetone every once in a while is not that big of a deal. It does have a pretty intense smell, but so does ethyl acetate. They both have pretty strong smells. So acetone is a nail polish remover, still sold over the counter. I think the main reason that we've moved away from using acetone as nail polish remover is just because it's very drying to the skin, and ethyl acetate is not quite as drying. Another more interesting application of acetone is that we can actually produce it in our bodies. We can produce acetone. It is not normal for our bodies to be producing acetone, and in some cases it's an indication that something might be wrong. We produce acetone in our bodies essentially when we are starving for glucose, when we are unable to metabolize glucose. Our bodies do a ton of glucose metabolism. That's where we get the majority of our energy, through the metabolism of glucose. So when our body needs energy and we're not able to metabolize glucose to get that energy, we start metabolizing other stuff. When we're unable to metabolize glucose, we are going to start metabolizing fats, and also protein. And one of the byproducts of fat and protein metabolism is acetone. Acetone is produced in this metabolism. So when would this actually happen for a person? Because this is not a common situation or a normal situation. This would take place, this happens if a person is starving, if it has been a very long time since they've been able to have food and they have no glucose stores anymore in their body, so they're turning to fat and protein. Sometimes this is an intentional starvation. Sometimes it's a byproduct of an illness. The keto diet is designed to force you into this state where you are metabolizing your fat and protein and producing the ketones, which is where the name comes from, such as acetone. The other situation where this could happen is when we're dealing with someone or something who is diabetic. So this happens during starvation, and it also happens during unmanaged diabetes. Because many of you have interest in the healthcare field, you probably have a pretty good idea about diabetes and what it entails. But basically, diabetes is your body's inability to properly store, manage, and metabolize glucose. So if a person, or like my dog who happens to be type 1 diabetic, has something going wrong with their diabetes treatment, maybe they forgot to take insulin, or maybe they haven't been diagnosed yet, or maybe their insulin is no longer effective, or maybe they ate a large quantity of high glucose foods that the insulin hasn't kicked in yet. In that case, when a person is not metabolizing their glucose properly, they start metabolizing fats and proteins. And with these individuals that I've noticed with my dog, when she's having a problem with her diabetes, you can actually smell the acetone on the person's breath or the dog's breath. I'm just going to specifically say my dog's breath. When she's not feeling well and the diabetes is not going well for her, her breath is a combination of hot garbage and warm acetone, which is super disgusting. But anyways, these are 5 different aldehydes and ketones that you are encountering in your everyday life. Probably not formaldehyde, but acetone and cinnamon and vanilla and citronella.